Hello, once again, we are going to start an introduction to OOPs using C++. We are going to start C++ fresh. C++ is basically an object-oriented programming language. When I say object-oriented programming language, it means emphasis is on data. Everything is centered around data. Okay. In any other programming strategy, in structured programming style like C, emphasis is on algorithms. Emphasis is on how to do things. But in C++, it is not like that. In C++, it is an object-oriented programming. So when I say object-oriented programming, I mean emphasis is on data. Suppose this is your data. Okay, the all-important data. Now, why I say all-important? Think of a scenario that there is a bank. Okay, and inside the bank they use electronic systems, computers. Suddenly there is a crash. Okay, think, what will the bank manager be worried about? Will he be worried about the crashing systems, or will he be worried about losing data?
Data.
Data. He will be worried about losing data. So, because data is more important than systems. On another scenario where a pilot is flying an aeroplane, okay, and there is going to be a system crash, which may threaten the aeroplane may fall down, or will he be worried about the system crashing, or will he be, that is the data, and will he be worried about the procedure or the passengers? System or passengers? Will he be worried about data or systems, the pilot? What do you feel?
So I guess you worry about both
About?
the data as well as passenger, the pilot.
Now, suppose the plane is going to crash from 10,000 feet, and pilot will be thinking about data,
Also, he will be thinking about passengers.
about the system that should not malfunction,
Yes.
that should work properly, isn't it? So these are two
Yes.
different scenarios. A scenario in which the system is more important than anything, and a scenario where data was more important than anything. Okay, so the scenario in which the data is the most important thing, where the emphasis is on data, there we use OOPs. Emphasis is on data, not on procedure. On the languages where the emphasis is on systems, the emphasis is on procedure, the emphasis is on algorithm. Such programming languages are called structured programming. Whereas other programming languages where the emphasis is on data, primarily on data, such programming languages are called OOPs. OOPs programming language where the emphasis is on data. So, OOPs is a program design strategy. It's where the emphasis is on data. Okay. How? Suppose this is the data. Now suppose in your program you are declaring data something like this. Int I. Now when you declare a variable int I, tell me yes and no. Did you describe? Okay, you have described that I is an integer and it will store integer value, fine. Did you describe what operations will be performed on I? Will you do increment, will you do decrement, or will you do division, modulus, or whatever operations you will do, left shift, right shift, you can do any kind of operation on I. Did you describe the operation?
No. No, sir.
No. So in C what happens, you just declare the variable or a constant. You declare a placeholder basically. But in C++, when you have to declare some data item, you also declare operations that will be performed on data. That is OOPs. So you also have to have the operations that you want to perform on data. Along with data, you can't just go ahead, declare data and go keep your data in there. No. So what operations you will perform on data, that also has to be declared at the same time. Okay, and you have to have this relationship between the data and the operations. Then this is object-oriented programming strategy. So whenever you have data, you have to have described the operations also that you're going to perform on data. Okay, so this is data section and this is the operations section. Data is data element like int I, whatever you can declare. Operations will be implemented in terms of functions. Okay, so this both the things put together is called a class. Both the things put together will be called a class. Class is nothing but putting together your data and the operations on data, okay, will be called class. And this is the emphasis is on data. How? Like this. OOPs is a relatively new approach to programming. It supports the creation of new data types and operations, new data types and operations. To manipulate those types, data is protected, very protected. Okay, so let us put these important points here. When I say emphasis is on data, so look at that, data is so protected in here. Isn't it? Then data is protected. You see, I draw the arrow from operations to data, means you cannot reach data directly. One cannot reach or access data directly. The access have to be operations. So data is protected. After all, emphasis is on data, isn't it? There are many types of programming languages. All this is theory. I'm not going to cover it here. Like theory you get read. I'm going to concentrate primarily on object-oriented programming. Now, OOPs treat data as a critical element. Data is a very critical element. There is no external access to data. Nobody can access data directly. Try to access data from outside of the class. Suppose you try to access data from somewhere outside of the class, from anywhere. You don't have these access. These access are prevented. The only access is through here. Let you see this. This is the only access to the data. Nothing else. This is a valid access. Right? Now, this brings in great levels of abstractions also, where the data is hidden from the rest of the world. The object-oriented programming ties closely the functions to operate on it. The functions to operate on data are tied closely in something called class. Protects the data from accidental modifications from outside the function. Okay. So another important point, but the pointers I am writing here, you must remember these at all times. Builds data and functions around these objects. Now what will happen? Suppose int, I have a data type int. Okay. Can you store value in int? Or will you store value in an instance of it? Now here what happens, let me tell you about this. What is this int? This int is a data type. Okay. And what is an I?
Variable name.
It's an instance of integer. Why I say instance is because it is only when you declared I that you got some memory. When we are talking about only int, was any memory allocated? The answer is no. But when you declare an instance of I, then instead of integer, that is when you declare I, it is then that the memory was allocated 4 bytes, isn't it? Now this class which has certain data, which has certain operations put together, is also data type, like int. Int is a primary data type, inbuilt data type, isn't it? But the class is as a whole is a user defined data type in which you are defining that the class have what data, that the class have what operations that are being performed on data. All these things are being described in the class, which is a data structure which you are designing. But as you can't, no memory is allocated when you design int. Similarly, no memory is allocated when you design class. Memory is allocated when you declare an instance of int. Similarly, here the memory is declared only memory is allocated only when you declare an instance of class, which is called object. Okay, which is called object.